In this video, you'll be introduced to the idea of indirect proof. Now, before we get into how to write one, let's talk a little bit about when we might want to write one. So the indirect proof is used most commonly, most frequently, to prove that something is not true. For instance, if we were to jump right down into example 1, we can see that what we're trying to prove here is that angle 1 is not congruent to angle 2. So I think that's probably the most important place to get started, is knowing when it's going to be most appropriate to use this method of proof. So use for when you're trying to prove something is not true. The steps that you're going to follow is we're going to start by assuming the opposite or the negation of the prove statement, or the statement in the prove. So assume the opposite or the negation of whatever statement it is that you're trying to prove. This is really important to pay attention to, because most likely, not always, but most likely, there will probably be a couple statements with the word not in them. You want to start by assuming the opposite of the one that's in the prove. And then what we're going to do is we're going to establish what's called a contradiction. And a contradiction is two things that can't possibly both be true at the same time. And interestingly enough, when you come back to class, I'll share with you a little example of where you might use this in real life. It really doesn't have anything to do with geometry, but it is a really neat application of the indirect proof. So, and I can't spell and talk at the same time here. So establish a contradiction. Let's go back and fix that. And again, that contradiction is just two things that can't possibly coexist together at the same time. And then once we've established a contradiction, we know that the statement that led us to the contradiction, this opposite of the proof, he must be a bad statement. So we can go ahead and conclude whatever it was that we were trying to prove must be true. Like anything else, when we try to spell the math out in words, it ends up being a little bit more confusing than it actually is when we just look at the math in terms of math. So let's go ahead and let's see if we can't follow these steps to make some sense out of this very first proof. In example 1, we're given that lines M and N are not parallel, and we're being asked to prove that angles 1 and 2 are not congruent. Well, if I follow the steps that we were given up above, we're going to start by assuming the opposite of the statement that we're trying to prove. So in this case, the statement that we're trying to prove is that angle 1 is not congruent to angle 2. Well, the opposite of that would be angle 1 is congruent to angle 2. So that's how I'm going to go ahead and begin my proof. I'm going to begin my proof by assuming that angle 1 is congruent to angle 2. My reason here is that I'm going out on a limb and I'm making an assumption because I want to figure out where that assumption will lead me. Once I've made the assumption, I can go ahead and I can actually mark the assumption in the diagram. And I can't help but notice that in this diagram, angles 1 and 2 are corresponding angles. So at this point, we've got ourselves a pair of congruent corresponding angles. And you should know from your study of parallel lines that the congruent corresponding angles tell us that lines M and N must be parallel to each other. Because anytime we have congruent corresponding angles, that means our lines are parallel. It's going to be fairly simple to establish our contradiction in this proof, because the one and only given statement for this proof is that line M is not parallel to line N. So here's our two contradictory statements. We've got on one hand that line M is parallel to line N, and in the given we're told line M is not parallel to line N. Well, it can't possibly be both of those, so those are contradictory statements. It has to be one or the other. They can't possibly be both true at the same time. So because we have these two contradictory statements, we know that the statement that led to that contradiction, angle 1 being congruent to angle 2, must be a false statement. And if that's a false statement, then its opposite or its negation, in other words, angle 1 is not congruent to angle 2, must be the true statement. And our reason here is because we had that contradiction. So this is going to have a lot of similarities to the proofs that we've written all year long, with two major differences. The one major difference is that we're going to start by assuming the opposite of the proof. And the other is that our reason usually here at the end, or always at the end, is going to be because we've established some kind or some form of a contradiction. All right, some of you are wondering, is it possible to write a two-column proof that's an indirect proof? And the answer to that is yes. So let's go take a look at this question number 2, see if we can't maybe this time formulate a two-column proof that is also indirect. So this one too, again, the clue, the hint, the major warning flag that tells us that we're going to have to use this indirect proof here is the fact that we're being asked to prove that two things or these angles are not congruent to each other. So again, my assumption is to start, or is to begin, by assuming that those two angles are congruent. And once I've assumed it, I can go ahead and mark it in the proof, mark it in the diagram. The other piece of information that I can mark in the diagram is the statement that segment AB is congruent to segment BC. The other given that we're dealing with here, notice that that has a not in it. It's really tough to mark things that aren't true in the diagram. And for that reason, I'm not going to mark it, but rather I'm going to save it for my contradiction. That's what I'm going to try to use in order to establish my contradiction. So I'm looking at this picture and I'm seeing some overlapping triangles here. Remember from way back when that the strategy that I gave you to deal with overlapping triangles was to separate them. So the very first thing I'm going to do is separate the green triangle from the yellow one. And the green triangle is triangle BDC. The yellow triangle is triangle BEA. And I can't help but notice that they share this angle at the top in common. So angle B is going to be congruent to itself. We had angle A congruent to angle C. I'm going to go back and fix my original diagram with two arcs to indicate that those two angles are congruent to each other, but not the same as the reflexive angle B up at the top. And segment BC is congruent to segment AB. So I'm seeing here congruent triangles via angle side angle. And you may be saying to yourself, wait a minute, we're trying to prove angle A is not congruent to angle C. Why are we proving congruent triangles here? Well, when in doubt and you don't know what to do, you can almost never go wrong by proving a pair of congruent triangles. So that's where I'm going to start. And again, if we can connect this back to some ideas that you're already familiar and comfortable with, it's going to be so much easier. So angle A and angle C were my first pair of angles. So I'm just going to go ahead and start by proving my triangles congruent to each other. And once we get there, we'll see where that has gotten us or what that has enabled us to do. So this, I promised you, a two-column proof. I'm going to go ahead by getting some statements and some reasons down on paper. I will almost always start a two-column proof or any kind of indirect proof with this assumption. You could start with the given information, but I'm going to start with the assumption. So angle A is congruent to angle C. That's an assumption that we're making just so we can kind of see where that takes us and what we get as a result of assuming that those two angles are congruent to each other. Those are a pair of angles in the triangles I was trying to prove congruent. Next thing I need to do is talk about that pair of sides. AB is congruent to BC. We know that's a true statement due to the fact that it's given to us to be a true statement. And then thirdly, angle B is congruent to itself by the reflexive property. At this point, we've now established through angle side angle that the two triangles are congruent. And when you're naming your two triangles, make sure you're very careful and match up their congruent corresponding parts. So how you name the first one, not so important, but when you begin or when you go to name the second one, you want to call it angle BEA. Sorry, triangle BEA. And that is, we said, due to angle side angle, using statements 1, 2, and 3. So here's the catch. Well, not really a catch. Once we know the triangles are congruent, we know that all the corresponding parts are congruent as well. And it just so happens that segments BD and BE are corresponding parts of the triangles we just proved congruent to each other. So now I can go ahead and use CPCTC to say that segment BD has to be congruent to segment BE. You probably realize at this point exactly where I'm headed with this, which is going to be in direct contradiction of the statement that was in the givens. In the givens, we're told that segment BD is not congruent to BE. So again, that contradiction will be two statements that can't possibly both be true at the same time. In this particular case, these two cannot coexist in our universe as we know it and both be true. Either the segments are congruent or they're not. So there's our contradiction. Because we established this contradiction, we know that the assumption that led us to this place, this statement that angle A is congruent to angle C, must be a false statement. And if it's a false statement, then its opposite or its negation, which is that angle A is not congruent to angle C, must be a true statement. Now, here's one thing you need to be very aware of when you write a two-column proof that's also an indirect proof. We have this contradiction, which is a word that I'm having a really hard time spelling and talking about at the same time. You need to make sure you cite the two statements that establish the contradiction. So the contradiction exists between statements 5 and 6. That's really important for an indirect proof, that you make sure you remember to cite which two statements the contradiction exists between. Okay, as always, thank you for the gift of your time and watching the video. I hope that it was worthwhile and that you learned something. As always, I'm going to ask that you take a few minutes and think about and reflect upon what you've just seen and why it might be important, and then see what you can do with that proof there on the next page.